Higher education institutions and researchers have, in many regards, pioneered the use of high-performance computing and the development of artificial intelligence and machine learning. But many of those leading those institutions are often less clear about how AI and ML can actually be put to wider use at college campuses and universities. Here to talk about that today and the expanding use of AI and ML in higher education are Jerry Sheehan, Vice President for IT and Chief Information Officer at San Diego State University, and Howard Locke, AI and Machine Learning Business Development Specialist at Hewlett Packard Enterprise. Jerry and Howard, thank you so much for joining us.
Thanks a lot, Wyatt.
So Jerry, let me start with you and ask you to set the stage a little. Describe SDSU's AI ML journey around AI, some of the challenges maybe that your officials were trying to address, maybe some of the key steps that you took or still taking to put AI into production, and talk a little also about the rationale behind high performance computing environments that you set up in different schools.
Sure. Thanks very much, Wyatt. So San Diego State University's journey with machine learning and artificial intelligence, it really has been underway for more or less the last decade. And I think one of the important things to think about that journey is the fact that it, much like great innovations that have happened between the public and the private sector, involves a fair deal of partnerships. There's a good deal of innovation in terms of the development of novel approaches that are happening in algorithmic space. Those then often interact with data or commodity resources from vendors in the private sector. And one of the things that we have seen and appreciated is this delicate ballet that happens between innovation and scalability. So from San Diego State University's perspective, one of the reasons that we have looked at this as a strategic opportunity and growth area is because of the demonstrable need in the sciences to look at larger data sets. And there's been some great publication recently by Dan Reed, Mr. Gannon, and Mr. Dungera looking at the future of high performance computing. And one of the things that they noted is that essentially we've moved away from boutique high performance computing architectures into things that are dominated by Intel and AMD right now. And importantly, over the course of the last 6-7 years, we've really seen graphical processing units take off as the way to accelerate that. So from an SDSU perspective, that's been critical from research problems that we've had that are big data problems. SDSU, through a partnership with the University of California, San Diego, is an active player in the Pacific Research Platform, which has essentially taken next generation concepts, some of the open source tools from companies like Google in terms of the creation of the Kubernetes as a way to do containers, and then moved into being able to harvest across multiple institutions the synergy that comes of all of us working together to solve scientific problems. Then over on the administrative side, there are a variety of wicked problems that are really digital footprint problems for our students. All of the patterns that we see right now that are beyond our ability to individually analyze, analyst at a time, that open to machine learning opportunities. So happy to talk more about those, but it's that strategic intersection of commoditization, innovation through faculty and staff working together to create tools that we can take to school and apply to student problems.
I'd love to put a spotlight on maybe some of the outcomes of that. Can you describe maybe a use case where AI and ML is really advancing your institution's research work, and perhaps additionally, how it's helping in other areas like student success?
Sure. Let me talk about one that's focused first on student success. That's research that we did with our private sector partner, Pearson's. And one of the things that we wanted to understand was how soon can you know if a student is having problems in a course? And one of the ways that traditionally universities have done that, also taking machine learning approaches, is to go back and look at the learning management system. Is the student engaging in the learning management system? But one of the things that we recognize through our partnership with Pearson's is there's an awful lot of supplemental instructional materials that are now provided that students are interacting with that are outside of the LMS. So through that partnership, we were able to get access to the data that Pearson's had, marry that together with what we had in the learning management system, and then begin to look at if we could understand early indicators of student success. Some of those things were patterns that we would have known before, but we wouldn't have been able to prove. For example, how students interact early on with homework is a great example of if they're going to be successful or not in a course. Now, that's not a revolutionary finding, but the fact that we could validate that it's statistically significant and that we could also get that signal quickly across lots of folks is important. I think another area that really is interesting in terms of student success in science is some of the ways that we have algorithmically, computationally, to look at some of the biases that come in some of the problems that are inherent. So in supplemental instruction, one of the classic problems is the people who go into supplemental instruction tend to be students who are high performing. So to see gains from them engaging make you wonder about if those would actually transcend. We were able to take statistical methods that had been developed in a package referred to as CME, apply that inside of our studio, and essentially look for students who were not part of supplemental instruction, who were taking similar courses, who in a sense were almost a digital nephew of students who were already there. So we could look at students who we thought would be advantaged and make the argument back to them that they were very similar to students who were already successful. So I think it's that conversion of the literacy of data into something that's actionable that's really important in those student success efforts. So that's an effort in supplemental instruction. If we were to move over to something that's more pure research, but again, applicability back to our student population, there's great research that's been done by Dr. Paolini along with some of his students in the Internet of Everything lab that we have that's looked at being able to apply machine learning vision algorithms to looking at the challenge of skateboarders crossing very busy intersections. We have an area in Chula Vista that's actually, I think, in the top 10 for collisions in the United States. We're able to partner with those areas to get access to camera data that already existed, to use machine learning algorithms on GPUs to accelerate the ability to see when there could be collisions, and then to think as we embrace the next degree of commoditization, edge computing, if you could move those signals back to devices that would prohibit collisions. And I think that speaks to all of the transformative power of these approaches, all based on commoditization of hardware and just the great acceleration that we've seen through companies like NVIDIA in particular.
I love the practicality of that. Well, Howard, let me bring you in here at this point. You have a kind of a wider scope of view on higher education institutions. Describe what you're seeing at colleges and universities regarding advanced uses of AI and ML, and maybe touch on, as well on the evolution of high performance computing at higher education institutions that are also taking advantage of AI.
Sure. I want to pivot off of what Jerry talked about. There's a lot of topics that Jerry talked about, which starts with sort of a level of insight, which translates into hypotheses around certain business problems, whether it's student success or campus safety, or helping researchers and data scientists actually lean further into their technology so they can experiment faster. That's where really HPE excels. We have obviously world-class compute resources, but compute resources alone are really not the single most successful ingredient, right? Talent matters. I think Jerry will agree. The talent of the researcher is extremely important. Horsepower from compute networking and storage is important, but more increasingly, the stack on top of that allows the abstraction of all of that heavy lifting, the management of the compute and IT infrastructure, so that data scientists can focus on what they do best, which is building models, understanding patterns of data, and then deriving insights from them. So I think that's an area where we're really leading into. And when we're successful, we address sort of the challenges of the builder that can go from business problem to hypothesis to a solution. And we can address things like student success that stems from better understanding of their sort of learning behaviors, right? What can we harness? And I know Jerry didn't touch on it, but it's something that's part and parcel of how we operate in the context of educational institutions is ethical AI, right? It is something that is imbued in just about everything we do, particularly ethical AI as it relates to computer vision analytics. It can be a very controversial area, but AI can really help college institutions do three things extremely well. Research is quite important. I think I've seen educational institutions achieve a level of preeminence because they are doing, leading edge research, whether it's in health and human services or, computational science or physics. We can help organizations do that. The other area is sort of creating a campus environment that suits the student, right? In sort of the daily lives of that student. And then the third area is how do we harness insights from the vast amount of data that we can extract from that environment in a way that is ethical, in a way that is not intrusive. So I think simple things like use of bots, chat bots, right, that can disseminate information that is of routine nature, that responds to students in the way they want to consume and ingest information. Something as simple as that could be quite useful. Campus safety could stem from application of computer vision and computer vision analytics capabilities that is additive, again, not being intrusive. So I think it's just so many different ways where AI can be helpful. And then one final area where I think there's an enormous amount of potential is natural language processing, right? We're beginning to see a community develop that is harnessing the power of NLP based on data sets that are billions, right, multi-billions of parameters that hold tremendous promise in the way they might assist academic institutions.
Absolutely. Well, Jerry, back to you. Howard touched on a number of topics, ethics, natural language processing, and other elements. You're living in this world. Talk to us a little bit about some of the lessons maybe that you and your colleagues have learned recently regarding AI and its applications, and what recommendations would you make to your peers at other institutions?
Sure. Let's start by talking about the importance of sort of the ethical approaches that we take. I think one of the things that's important to remember in the history of how higher education has looked at dealing with student data is about a decade ago, most of those things didn't go through our institutional review board processes. We said, oh, that's an administrative use of data, and so we don't need to do what we would do on the research side. But the criticality of the institutional review board process, which came from the Belmont and also research and ethical concerns that were raised by National Institutes of Health, was to remember that in all of these efforts, we're dealing with human beings. And so I think one of the things that San Diego State University has helped pioneer as part of a community conversation is really the importance of looking at new frameworks for thinking about how we recognize that students are human beings when we're dealing with their data. And the best framework that we've found for that right now is the ASMR Convention, the sort of standards that were articulated back in 2014. There are 6 of them: respect for the rights and dignity of learners, benefits, justice, openness, the humanity of learning, and continuous consideration. All of those move into a recognition that while we're making decisions, that it's really critical to understand the impact of that to human beings, in this case students, and equally importantly, to be able to understand our algorithms. One of the things that San Diego State University is both convinced and convicted in is that we won't use algorithms that say, do this so you can get this behavior, if we can't understand why that behavior is occurring. And I think one of the challenges right now in some of the market forces is folks who think that algorithms are secret sauce so they can't be talked about, who want to sell universities solutions that say, if you do this, this will happen, but we can't tell you why. That's really deeply problematic because we as leaders still need to have a fair degree of skepticism. And I think as just one of the case in points, it's always important to remember that an algorithm is no better than the tuning environment that it's existed in. And when you look for potential at vision algorithms, a lot of them have been biased by availability of images online, which happen to be dominantly Caucasian. When we look at some of the monitoring software, which has looked at behaviors of, is that an aberration of what someone is doing on screen? Most of those algorithms were created in environments that were very constrained. However, what we saw in COVID was that those were not the environments that our students were in. And I think those differences, an algorithm trained for one environment that doesn't understand the difference, that flags students as potentially cheaters, potentially also has racial overtones, are just an indication of how wrong the application of science at scale, if you don't understand the system, can be. So it's important that we continue those open conversations. I'd also say I think it's really important that universities think about the importance and the monetization of the data that they have. And many vendors that we're working with in space are more than happy to work in partnerships that recognize the value of our data, but there are also a number of vendors who are more than happy to go to other universities and have conversations about, well, what we really need for your student success platform is just to have access to all of your student information system data that you've had for the last 30 years. There is an incredible value to that data that many universities are giving away as a way to get a signal. I think it's important that we think about the opportunity to be equal brokers, make sure that both sides are benefiting from something that demonstrates value back to both sides.
Great points. I appreciate your sharing that. And then Howard, just wrapping up here, talk briefly about maybe some practical steps that higher education officials should keep in mind in making AI and ML, part of their larger IT strategy at their institutions.
Yeah, I think that comes in kind of flavors. One is to support the research community. And then one is to provide sort of the instructional capacity for machine learning and AI, which I think is becoming quite important in our society. So with respect to supporting the researchers, I think I earlier mentioned that the tech stack actually matters, right? The compute resources, I think GPU intensive workloads are becoming more common because we're dealing with data sets are simply massive, right? I think what we ought to consider is certain institutions may be aligned with, and Jerry mentioned, Intel or AMD or NVIDIA, right? These are major players in the high performance computing environment, and they have certain pros and cons associated with the application of their technologies. So building out a tech stack that optimizes whether it's a GPU intensive workload or an IO intensive workload, right? Being able to optimize and tune that stack is quite important, and being able to tune that stack in the way that resource is actually consumed by the data scientist so that you can maximize its use. Proper sort of fractionalization of capabilities or proper scheduling of those resources are quite important because you've got lots of demand and a constrained resource. That is typically the case, right? So that's always the battle. Who gets their share of compute resources? Because increasingly data models or data sets are large. Model convergence takes weeks, right? Sometimes months. So that's something you've got to look out for. But on the instructional side, you have very similar sort of challenges. Right, you might have a student population of thousands that are competing against very limited resources. How do you make them available? There is almost a infinite range of portfolio of open source technologies and software that's out there, and your students are going to want to experiment with them. And the most exciting part I mentioned earlier is natural language processing. I think that is a very exciting and accelerating landscape. So I think being able to provide access, unfettered access to all of the open source technologies that are out there today, and then allowing the student body to be able to leverage that in a compute networking storage environment that helps them experiment in the way they want to. And at the end of the day, I think it's about faster experimentation, faster failing, and then being able to quickly identify what's working and what's not. And I'll mention one thing in support of what Jerry was saying. How do we ensure that we have fairness and transparency in AI? You have to use AI tools for that, but you have to look into the data and determine if there's bias in that data, right? And the most effective means to do that is the application of AI itself built into a sort of an end-to-end machine learning operations workflow.
Wyatt, if I could just amplify on one of the points that Howard made that I think is really important, it isn't an overstatement to say right now that high performance computing resources, in particular GPUs for instruction, given the data nature of many of our disciplines, are emerging as critical as a tool as a textbook would be or a wet lab would be to a science course. They are essentially the way that the work is done. Institutions that have those tools advance, institutions that don't have students who aren't prepared for how they will solve those problems in the real world. So it is the next generation of the impact of these technologies in the very essence of the pedagogy of instruction.
Well, Jerry Sheehan and Howard Locke, thank you so much for joining us today and sharing your observations and insights about AI and ML in higher education. And thanks to HPE and NVIDIA for making today's episode possible.
Thanks very much, Wyatt.